Have you ever wondered how machines like robots or smart appliances work on their own? That's what mechatronics is all about. The perfect teamwork between mechanics, electronics, and computing that brings technology to life. What is mechatronics? Mechatronics is a branch of engineering that combines mechanical, electrical, computer, and control systems to design smarter machines. It's basically the teamwork of mechanics and electronics, with the help of computers, of course, to make devices that can sense, think, and act on their own. For examples, robots, drones, smart refrigerators, and elevators all use mechatronic systems to move, detect objects, and make decisions without constant human control. The role of software and hardware. Hardware refers to the physical parts, the sensors, motors, and circuits. Software, on the other hand, acts as the brain that processes information and sends commands. Without software, the hardware wouldn't know what to do. Together, they make the system function smoothly and intelligently. Types of sensors and actuators in mechatronics. Let's start with sensors. These are the input devices that collect information from the environment. A temperature sensor, like a thermistor. A thermistor is a temperature sensor found inside air conditioners. It detects the temperature in the room and tells the system when to start cooling or stop when it's already cold enough. A light sensor, such as an LDR or light-dependent resistor, senses how bright or dark it is. Street lights use it to automatically turn on at night and off when it's bright again. A proximity sensor, like the infrared ones in automatic doors, detects when someone is near. Once it senses movement close by, it signals the door to open automatically. A pressure sensor measures air or force. In cars, it's used in tire pressure monitoring systems to warn the driver when the tires don't have enough air. And a motion sensor, like a PIR sensor, detects movement in an area. You can find it in automatic lights that turn on when someone passes by and turn off when no one's around. Next, we have actuators. These are output devices that perform actions. An electric motor moves robotic arms or machines, while a hydraulic actuator, like the ones in excavators, uses fluid pressure to lift or push heavy loads. A pneumatic actuator, found in bus air brakes, uses compressed air for motion. And a solenoid is used in door locks and valves to control movement using magnetism. And finally, a servo motor provides precise movements, especially in robots and RC cars. In short, sensors detect, actuators act. Together, they make a mechatronic system function smoothly. So now, let's proceed to how sensors collect data and actuators take action. When a sensor detects something, it converts that physical signal, like light or sound, into an electrical signal. That data is sent to the controller, which processes information and makes a decision. The controller then sends a command to the actuator, which performs the needed action. This is how an automatic door knows when to open or how a robot decides when to move. In mechatronics, signals are how data travels. Analog signals are smooth and continuous, like the waves of sound. Digital signals, however, are made up of zeros and ones. They are more exact and easier for computers to read. Most modern machines use digital signals because they're faster, more reliable, and less likely to be affected by noise. Signal processing is what happens after sensors collect raw data. It filters and cleans the signals so that only useful information is passed on to the control system. For example, if a temperature sensor picks up small unnecessary fluctuations, signal processing smooths those out. This ensures that machines react correctly and efficiently. To make communication between systems possible, we use converters. An analog to digital converter, or ADC, changes continuous signals into digital form that computers can understand. Meanwhile, a digital to analog converter, or DAC, turns digital data back into analog signals that control motors or actuators. This two-way conversion allows machines to process information and then perform real-world actions. Control algorithms are sets of rules that tell a system how to react based on sensor data. There are different types of algorithms depending on what the machine needs to do. For example, a simple on and off control algorithm. If the temperature goes above 30 degrees, the system turns on the cooler. Once it drops below 25 degrees, it turns the cooler off again. It's the most basic type of control. It only switches between two states, on and off. Next is the PID control, which stands for proportional, integral, and derivative. It calculates three things. P, or proportional, how far the current value is from the goal, and I, integral, the sum of past errors, and D, derivative, how fast the error is changing. It's often used in robots or motors to keep movements smooth and stable. For instance, keeping a robotic arm balanced or a drone steady in the air. These algorithms make systems more intelligent and adaptable, allowing machines to respond accurately to real-world conditions. In this video, we see a smart dustbin project that segregates waste into wet, dry, or metallic categories. It uses sensors to detect the type of material thrown inside. For example, a metal sensor identifies metallic waste, while moisture sensors detect wet materials. Once the sensors collect the data, it's sent to a microcontroller, which then decides which cabin to open. The servo motors or actuators move the lid automatically, directing the trash into the correct compartment. This mechatronic system shows how sensors, computation, and actuators work together to automate tasks and promote efficient waste management. Mechatronics has countless real-world uses. In cars, it's behind systems like anti-lock brakes and automatic parking. In factories, mechatronic robots assemble parts with incredible precision. And even at home, mechatronic systems are found in washing machines, air conditioners, and smart home devices. It continues to improve safety, productivity, and everyday convenience. To sum it up, mechatronics is a field that connects mechanics, electronics, and computing to build intelligent machines. It has transformed the way we live, work, and interact with technology. As our world continues to move toward automation, mechatronics will play an even bigger role in shaping the future.